All right, today we're going to take some time looking at LeetCode problem, valid Sudoku. Determine if a 9 by 9 Sudoku board is valid. Only the field cells need to be validated according to the following rules. Each row must contain the digits 1 to 9 without repetition. Each column must contain the digits 1 to 9 without repetition. Each of the 3 by 3 subboxes of the grid must contain the digits 1 to 9 without repetition. And notes, a Sudoku board partially filled could be valid, but if not necessarily solvable. And the field cells need to be validated according to the mentioned rules. All right, so what he says is for the first row, for first rule, we're gonna check each row to see if there any repetition or any duplicates inside of it. In this case, I think this board is valid. So the first row, it should be valid as well. But if we pretend this box is taken by another number is already here, let's say it's 5 and 5375, and gonna make it like invalid. So, and we're gonna return false in this case. And it goes to the column as well. If you have another 6 here, and this column is gonna be invalid. And we also have sub boxes. So each board should have like 9 sub boxes. And if you look at here, this is, so all those sub boxes should be valid. But if we add another duplicate in here, let's say 8 here, and then it's gonna be invalid. And also we don't have to care about if the board is really works or not when it comes to the completion of the Sudoku. All we need to care about is those numbers that's being given to us. All right, so hopefully you already have an idea of how the Sudoku works, any expectations this problem carries, and now let's look at the solution. Here we have a class solution, and we also have a Portal home-based function by which we're going to call other sub-functions to check the validation of like row, column, and sub-boxes. But first of all, we could just look at the row validation. This is also very straightforward. What we doing here is we take each row of the board, and then we also gonna pick up each number from the board, and we push it into a check table or an empty array list. And then later we're gonna use in keyword here to check if there's anything duplicated inside the array, the check array. If it exists, we're gonna just return false here. And otherwise we will append it to the check table. And at the end, we're gonna return true if there's no duplicate. And we're gonna repeat this process later for each sub functions. All right, so that's for the row, and for the column is gonna be very similar. If you notice that in order to get each elements column wise or vertically, we just simply swap the indices. For example, if you look at it, first of all, like horizontally, the indexes should be laid out like this, right? But when it comes to the column wise, in indices is going to be 1 0 and 2 0, 3 0 here. And then what we did, so you can see that the indices kind of like has been swapped, right? Like change the positions. So if you understand this concept, and it's going to be much easier for you to understand this the implementation of this function. So we simply just get the y indexes, like the vertical indices, and here we just call it j, and we pass into the valid column as the first argument. And here we just rename it as the column index for a better reference. And then we get the row index, which is going to be the vertical index, and then we just use those two indices to fetch the number, and then we save it into a current number. And then the same concept is going to be applied to we mentioned here and applied to here, and we just repeat the process. And for the third one, it's going to be a little tricky. It's tricky to check every single number inside each boxes, but we could see if we could split up like those boxes into like 9 boxes, it's all going to be to have something to deal with like 3 in index 3, 6, and 9. Of course, the first one is the first index starting at 0, so it's going to be a 2, 5, and 8. However, this the first loop, for loop, is going to help us get like 3, 6, 5, 3, 6, 9, and then we gonna pass in here as triplet, and it will be used later inside the second for loop. But the outer for loop, what it does is to create like an index from 0 to A, which means it's gonna be like 9 boxes. It's gonna be like the number of the boxes in total, and then we could just use this. We could just use another for loop, and it's gonna be saved as I index, which means it's gonna be the row index, and in the range starting from the triplet -3 all the way to triplet. If the triplet is 3, and the starting index is going to be 0, and all the way to 3. So that's why. So that's how we could check those boxes, like sub boxes here. And we have a secondary checkup here, which is another if statement. Since we want to break it up right after like one box is being validated, or like a set of boxes being validated, and we could just reset the interval count back to 0 and clear out the check table. And yeah, we just return true. Let me run the code to see if it works. All right, it works. And since we have check boxes like this, the space complex is going to be all of n. And also we only have the maximum 3 for loops for the last the box validation. And so this is going to operate like on all of n to 3, the power 3. Hope you find it helpful. See you next time.